Imagine if your bones could rebuild themselves, not just stop getting weaker, but actually reverse years of damage and become stronger than they were before. Scientists just discovered a biological on switch hidden in your cells that does exactly that, and they've already tested a compound that flips it. This isn't science fiction, this is happening right now, and it could change everything we know about bone health, aging, and osteoporosis. Every 3 seconds, somewhere in the world, someone suffers a fracture caused by osteoporosis. 3 million people in the UK alone live with this disease. In the US, it's over 10 million. That's millions of people living with bones that are literally crumbling from the inside. Porous, weak, ready to snap from something as simple as a sneeze or a gentle bump. Here's the really frustrating part. Until now, all we could do was slow it down. Every treatment on the market, every single one, focuses on just hitting the brakes on bone loss. But once your bones get weaker, that damage was permanent, or so we thought. But researchers from the University of Leipzig in Germany and Shandong University in China just published something extraordinary. They've identified a receptor in your bone cells. Think of it as a biological switch that, when activated, doesn't just stop bone loss. It reverses it. It builds new bone, stronger bone, even in bones that are already weakened by osteoporosis. And, get this, they've already created a compound that flips this switch, and it worked in their experiments. Not in a petri dish, not in theory, in living animals, with measurable results. Today, we're breaking down exactly how this works, why it's such a big deal, and what it could mean for the future of bone health. Trust me, if you or someone you love is worried about osteoporosis, you're going to want to hear this. Let's start by understanding what scientists actually found. The star of this story is a cell receptor called GPR133, also known by its technical name, ADGRD1. But let's stick with GPR133 because it's easier to remember. Now, before you glaze over at the term receptor, let me explain this in simple terms. A receptor is basically like a lock on the outside of a cell. When the right key comes along, a specific molecule or signal, it unlocks the cell and triggers a response inside. Think of it like a doorbell. Someone presses it from outside, and it causes something to happen inside your house. GPR133 sits on the surface of cells called osteoblasts. These are your bone-building cells, the construction workers of your skeleton. Their job is to lay down new bone tissue, constantly repairing and reinforcing your bones throughout your life. Scientists had known for years that variations in the GPR133 gene were connected to bone density. People with certain genetic variations had stronger or weaker bones, but they didn't know exactly how important this receptor was, until they decided to test it directly. Here's what they did. They engineered mice that were missing the GPR133 receptor entirely, just deleted it from their genetic code, and the results were striking. These mice developed weak, brittle bones as they grew up, showing all the hallmarks of osteoporosis, even though they were young and otherwise healthy. As biochemist Ines Liebscher from Leipzig University explained, when this receptor is impaired, mice show loss of bone density at an early age, mirroring what happens in human osteoporosis. So this wasn't just a minor player in bone health, this was a master switch. But here's where it gets really exciting. The researchers didn't just discover the problem, they found a solution. They developed a compound called AP503, designed specifically to activate this GPR133 receptor, and when they gave it to mice with weak bones, something remarkable happened. Where the bones got stronger, not just a little bit, significantly stronger. The compound triggered the osteoblasts to kick into high gear, producing more bone tissue and improving bone density. The researchers could actually measure the difference in bone strength after treatment. Think about what this means. This isn't a drug that just slows down the destruction. This is something that turns on your body's own repair mechanisms. Mechanisms that, for people with osteoporosis, aren't working properly. It's like finding the circuit breaker that's been tripped and flipping it back on. Okay, so we know GPR133 is important, and AP503 can activate it, but what's actually happening inside your bones when this switch gets flipped? Let's break down the mechanism. Your bones are in a constant state of renovation. There are two main types of cells at work here. First, you've got osteoblasts, the builders. They create new bone tissue, laying down calcium and other minerals to form the hard structure. Then you have osteoclasts, the demolition crew. They break down old or damaged bone tissue so it can be replaced. In healthy bones, these two processes are perfectly balanced. You're constantly breaking down old bone and building new bone at roughly the same rate. Your entire skeleton replaces itself every 7 to 10 years. Pretty wild, right? But in osteoporosis, this balance tips. The osteoclasts start breaking down bone faster than the osteoblasts can build it back up. Maybe the osteoblasts aren't working as efficiently. Maybe there are more osteoclasts than there should be. Either way, the result is the same. Net bone loss. Your bones become porous, full of tiny holes, like a sponge. This is where AP503 comes in with a double punch. When it activates the GPR133 receptor, it triggers a cascade of signals inside the cell. Research shows that it does two things simultaneously. First, it ramps up the activity of osteoblasts, those bone-building cells. It tells them, hey, we need more production here, time to get to work. The osteoblasts respond by producing more bone matrix, the framework that gets mineralized to become hard bone, and by laying down more calcium and other minerals. Second, and this is equally important, it inhibits the osteoclasts, those bone-breaking down cells. It essentially tells them to slow down, to be less aggressive in their demolition work, so you're getting a two-pronged effect, more building, less breaking down. The result? The balance shifts back. In fact, it shifts favorably toward building bone. You're not just stopping the loss anymore, you're actively rebuilding. The researchers could see this in their experiments. Bones that had been weakened became denser, stronger, more structurally sound. Now here's something really interesting that the researchers discovered. GPR133 isn't just activated by chemical compounds like AP503, it's also activated naturally by two things: the mechanical strain on your bones, meaning physical stress from movement and exercise, and interactions between neighboring bone cells. This is why exercise is so crucial for bone health. When you put weight on your bones, through walking, running, lifting weights, whatever, you're literally pressing that GPR133 switch. You're telling your osteoblasts, we need stronger bones here because we're using them. And get this, the researchers found that combining AP503 with exercise amplified the benefits even further. It's like giving your bones both the signal and the resources they need to rebuild. The compound provides the chemical activation, while exercise provides the mechanical activation. Together, they're even more powerful. Now let's talk about why this discovery is such a big deal compared to what we have now, because current osteoporosis treatments, while helpful, have some serious limitations. Right now, most osteoporosis drugs fall into a few categories. You've got bisphosphonates, drugs like alendronate or risdronate. These slow down bone loss by inhibiting those osteoclast cells we talked about. They basically tell the demolition crew to take a break. And they work. They reduce fracture risk, but they have some problems. Shown being blocked or inhibited by treatment. First, they can cause side effects, jaw problems, esophageal irritation, even rare but serious fractures in the thigh bone with long-term use. Second, they don't actually build new bone, they just slow the loss. And third, their effectiveness can decrease over time. Your body adapts. Then you have hormone replacement therapy, particularly for postmenopausal women. Estrogen therapy can help maintain bone density because estrogen is crucial for bone health. But here's the catch: hormone therapy comes with increased risks of certain cancers, blood clots, and stroke. It's a risk-benefit calculation, and for many people, the risks outweigh the benefits. There are newer drugs, like denosumab, which is a more targeted antibody treatment. It's effective but expensive, requires injections, and stopping it can lead to rapid bone loss, sometimes worse than before you started. And then there's teriparatide, which actually does stimulate bone formation, but it can only be used for a limited time because of potential cancer risks in animal studies. So here's the landscape: drugs that slow bone loss but don't rebuild it, treatments with serious side effects, medications that lose effectiveness over time, or therapies that work but are expensive and can only be used short-term. Not exactly ideal. Now let's contrast that with what targeting GPR133 could potentially offer. First, it's working with your body's natural bone-building mechanisms. You're not introducing hormones or antibodies from outside, you're just activating a switch that's already there. That potentially means fewer side effects because you're not fighting against your body's normal processes. Second, it doesn't just stop bone loss, it actively builds new bone. This is crucial. If you're a postmenopausal woman who's already lost significant bone density, you don't just want to stop the decline, you want to rebuild what you've lost. GPR133 activation offers that possibility. Third, the receptor responds to both chemical activation from compounds like AP503 and natural mechanical activation from exercise. This means it could work synergistically with lifestyle changes rather than being a standalone drug. And fourth, and this is exciting, earlier research from the same Leipzig University team found that activating GPR133 also strengthens skeletal muscle, so you're potentially getting a dual benefit: stronger bones and stronger muscles. That's particularly important for older adults, where both bone and muscle loss are major concerns. As molecular biologist Julianne Lehmann put it, the parallel strengthening of bone highlights the great potential this receptor holds for medical applications in aging populations. You're not just addressing one problem, you're addressing the interconnected issues of skeletal health and muscle strength that go hand in hand. Now, I need to be clear here. This is still early research. AP503 has been tested in mice, not humans yet. The pathway to human clinical trials will take time. We need to confirm it's safe, determine proper dosing, identify any potential side effects, and prove it works in people across different populations and ages. Let's zoom out for a moment and talk about the bigger picture, because this research has implications that go way beyond just treating osteoporosis in elderly patients. First, there's the aging population crisis. By 2050, the number of people over 60 will more than double to over 2 billion worldwide. That's a massive increase in people at risk for osteoporosis, fractures, and the complications that come with them. A hip fracture in an elderly person isn't just painful, it's often a life-altering event that leads to disability, loss of independence, or worse. Having a treatment that could not only prevent but reverse bone loss would be transformative for healthcare systems worldwide. We're talking about fewer fractures, fewer hospitalizations, fewer surgeries, and better quality of life for millions of aging people. The economic impact alone would be staggering. But it's not just the elderly who could benefit. There are younger people with genetic conditions that affect bone density, people with hormonal disorders, cancer patients whose treatments damage bone health, and individuals taking medications like corticosteroids that cause bone loss as a side effect. And then there are some really interesting edge cases. The research mentions potential applications for astronauts. Why? Because in the microgravity of space, bones lose density rapidly, about 1 to 2% per month. Astronauts on long missions to Mars or extended stays on a space station could face serious skeletal problems. A compound that activates bone building even in the absence of normal gravitational stress could be crucial for long-term space exploration. We're talking about enabling humanity's future in space by solving a fundamental biological problem. There's also the athletic and recovery angle. Could GPR133 activation help athletes recover from stress fractures faster? Could it help people rebuild bone after prolonged bed rest or immobilization from injury? The researchers found that combining the compound with exercise enhanced benefits. That suggests interesting possibilities for sports medicine and rehabilitation. Now, here's where it gets even more interesting. The Leipzig team's earlier research showed that GPR133 activation also strengthens skeletal muscle. This suggests the receptor plays a role in overall musculoskeletal health, not just bones. Could future treatments target both systems simultaneously? Imagine a therapy for sarcopenia, age-related muscle loss that also strengthens bones, or treatments for muscle-wasting diseases that prevent the secondary bone loss that often accompanies them. We're potentially looking at a unified approach to skeletal health that addresses multiple interconnected systems. There's also the personalized medicine aspect. Not everyone responds to current osteoporosis drugs the same way. Some people have genetic variations that make certain treatments less effective, but GPR133 is a fundamental part of bone biology. Targeting it might offer more consistent benefits across different genetic backgrounds. Of course, we need to be realistic. The path from promising animal studies to approved human treatments is long and filled with challenges. Many drugs that work beautifully in mice don't translate to humans. Safety testing takes years, and even if everything goes perfectly, we're probably looking at a decade or more before something like AP503 could be available as a prescription treatment. But the fundamental discovery here, that GPR133 is a master regulator of bone strength, and that it can be activated to rebuild damaged bone, that's groundbreaking regardless of how long the development takes. This research opens up an entirely new avenue for bone health that we didn't have before. So, what does all this mean for you today? If you or someone you love is dealing with osteoporosis or worried about bone health, here's what you should know. First, this research is real and promising, but it's still in the animal testing phase. Don't expect a GPR133 targeting drug at your pharmacy anytime soon. The scientists need to conduct more studies, eventually move to human trials, and navigate the long regulatory approval process. But the foundation is solid, and this is definitely something to watch. Second, the discovery that mechanical strain activates GPR133 reinforces something we already know but often don't prioritize. Exercise is crucial for bone health. Weight-bearing exercise, walking, jogging, dancing, strength training, actually triggers your body's natural bone-building mechanisms. You're pressing that GPR133 switch every time you move. If you're at risk for osteoporosis or already have it, talk to your doctor about appropriate exercise. Even simple activities like walking can make a difference. The research showed that exercise combined with GPR133 activation amplified the benefits, which suggests that even without AP503, exercise alone is activating these pathways. Third, don't abandon current treatments while waiting for new ones. The medications we have now, despite their limitations, do reduce fracture risk. If your doctor has prescribed something for osteoporosis, keep taking it. This new research doesn't invalidate existing treatments. It offers hope for better options in the future. Fourth, remember that bone health is multifactorial. Diet matters. Calcium and vitamin D are crucial. Lifestyle matters. Smoking and excessive alcohol harm bones. Overall health matters. Conditions affecting hormones, gut health, or inflammation can all impact your skeleton. The GPR133 discovery is a piece of the puzzle, not the entire solution. And finally, this research is a reminder of something important. Aging doesn't have to mean inevitable decline. For too long we've accepted that bones getting weaker is just part of getting older, but science keeps showing us that biology is more flexible than we thought. We can intervene. We can reverse damage. We can maintain and even restore health. The discovery that we can flip a biological switch and rebuild bones that were already damaged, that's profound. It challenges our assumptions about what's possible. And it's not just about bones, it's about muscle, it's about mobility, it's about independence and quality of life in our later years. Your skeleton is not a static structure. It's alive, dynamic, constantly rebuilding itself, and apparently, hidden in your bone cells is a switch that, when activated, can strengthen bones even after they've weakened. That's not just interesting science, that's life-changing potential for millions of people. The researchers at Leipzig University and Shandong University have opened a door to a future where osteoporosis isn't a permanent condition, where elderly people don't have to live in fear of fractures, where astronauts can explore space without losing bone mass, where your skeleton can stay strong for your entire life. That future isn't here yet, but the fact that it's possible, that changes everything. If you found this breakdown fascinating, if you love learning about the cutting-edge science that's shaping our future health, hit that subscribe button and turn on notifications. We're exploring the latest breakthroughs in medicine, biology, and human health every week. Drop a comment and let me know. Are you worried about bone health? Do you have experience with osteoporosis, either personally or with a loved one? What do you think about this research? Exciting or too early to get hopeful? I read every comment and I'd love to hear your thoughts. Thanks for watching Mind and Marvel, where we explore the incredible breakthroughs that are reshaping what it means to be human. Remember, your bones are rebuilding right now as you watch this, and science is figuring out how to make them rebuild even better. Until next time, stay curious, stay active, and take care of those bones.